Okay, so yesterday when I solved this February March 065 P4 paper, February March 2026 paper, I have done a few mistakes that I would like to correct here. And the first mistake that I've done is in the question number two, part A, subpart 3. I wrote that up thrust is supposed to be equal to weight when I have this solid steel cube sinking into the seawater. Well, a steel cube has a density of 7900, which is greater than that of seawater. So, of course, it's going to sink. I wanted to pair it up with another uh, uh, fact here that could have supported my answer to be for it to be a full proof answer, and that's why I said upthrust is equal to weight, where it's actually not correct. Weight of the object should be larger than the upthrust. Only then can you have a thing sink. So that was a mistake. Upthrust should be smaller than the weight, or weight should be greater than the upthrust. Only then will you have the thing go sink. Okay. And the second one, well, I wrote the spelling of dissipated wrong here. It's supposed to be dissipated. That is the spelling you want to keep up here. And the third mistake, well, this is a transformer question. I would like to explain this with a little bit of a diagram, and it'll help. In this question, there's supposed to be a transformer with the primary coil and the secondary coil, and you have 230 volts of output on the secondary coil. So you've got, this is your secondary coil, this is your primary, 230 volts. Okay, okay. So 230 volts on the secondary coil, and we have about 43 turns on the secondary coil, and we have what else do we know about the secondary coil? Um, yeah, there is a 2.2 kilowatt kettle connected to the secondary coil. And for the primary, we have already calculated the input voltage. It's a 33,200, or to be exact, it's a 33162.79 volts. And we have about 6,200 tons here. And um, what else do we know? Okay, nothing besides that. And we are supposed to calculate the current in the primary coil. So the current here is what we are trying to, oh, sorry, current in the primary coil. I'm doing the same mistake again. Current in the primary coil is what we are looking for. Um, so, the most important thing for you to remember here is, if it is said that the transformer is 100% efficient, the output power, which is a 2.2 kilowatt on the secondary coil, is going to be the same on the primary. That is what it means when it says 100% efficient. It means that the transformer is transmitting that amount of power, that is transferring that amount of power with 100% efficiency. If it is to be 2.2 kilowatts on the secondary, it is supposed to be 2.2 kilowatt on the primary also. So the power out input to the transformer is also 2.2 kilowatt. And that is what we're going to use to figure out the current in the primary circuit. We have a formula, we will use it right away. And so this all emitted, omitted, and we go, power is supposed to be V into I. Power for the primary is also going to be 2.2 kilowatts, so that is 2200 watts. Voltage we know is 33162.79, and the current in the primary is what we are looking for. When you do it, it comes out to be about 0.066 amperes, and that was the mistake, 0.066 amperes. So that was the mistake. And And like I told you, the most important thing for you to remember, it's gonna be the same power in the primary as it was in the secondary. Okay. Huh. Now, what they do here is they ask you to sketch the path. This is the ninth question. They ask you to sketch the path of the alpha particles and the gamma particles when they enter this electric field. Later in the part C, they ask for you to explain the path of beta particles if they were to enter instead of alpha and gamma particles here. So if the beta particles are to enter, of course they're going to be attracted towards the positive plate. If the beta particles are supposed to enter, of course they're going to be attracted towards the positive plate, and that's what I wrote. But there is one thing that I'm missing. The fact is, if alpha deflects this way and finds itself attracted to the negative plate, the beta particle is also going to deflect towards the positive plate, but the angle by which it deflects is going to be far larger compared to that of alpha particle, and that is the thing I need to mention here. So in a way, the alpha particle deviates about this much. So my explanation should contain the fact that beta will go deflect at a very large angle compared to the alpha particles. The reason is beta particles are far more lighter. So when they are attracted and they deflect at a very large angle. And that is something missing in my answer. So I should correct it here. Beta particles are fast moving electrons, negatively charged, so they are attracted to the plate. And you want to say plate P, which is the positive one, uh, plate which is positive. So I'll write it. They're attracted to the positive plate P. They deflect at a larger angle. They deflect by a larger angle is a correct word. Deflect by a larger angle compared to alpha particles because they are lighter in mass comparatively. That's one way I would like to keep it. Okay, so that was your entire thing about my corrections. So question number 2A3 we have corrected. We have corrected the spelling here. We have corrected the transformer question, and we have corrected the one point we have missed in the previous attempt. That's it. I'll see you. Bye.